Okay. So what about now? Has it loaded?
Nope, still loading on my end.
Oh, it's still loading on your hand. Okay.
Okay, it's up now.
Okay. Thank you so much for confirming that. Okay. Good morning, everyone. I want to welcome you to my lecture today. Of course, today is basically going to be the last lecture of this summer semester. Tomorrow, I'm just going to walk you through practice questions. Give me 1 second. So, like I said, tomorrow I'm going to walk you through practice questions. Of course, I've published, some possible questions for the final on the announcement section. And of course, I'm basically going to choose my final questions from there, word for word. Does that make sense? So, what I need you to do is just get yourself familiar with those questions. Okay. Okay. So today, oh, go ahead. Oh, do you get notes on the final? Is that what you mean? Yeah. You're actually going to have like, I'm going to allow two sheets, which is going to be 2 pages. Like it could be two sheets one-sided or a single sheet two-sided. You get what I mean? So that's what I'm going to allow. You can type it, you can write. There's no problem at all. Okay, so I want to walk you through the final topic of the semester. Of course, one of the 5 questions in the exam is going to come from what we want to do today. So I basically need you to pay attention. This is still taken from chapter 6 of the textbook. So we call this order statistics. So in the outline, I'm going to walk you through the concept of order statistics and also walk you through an example. But let me tell you this, just like what I've been doing from day one, what is the significance of other statistics in real life? Why do I need to pursue other statistics? Okay, before I walk you through the statistical or mathematical, architecture of other statistics. Give me 1 second. Before I'm going to walk you through that, I will need to first tell you what is the meaning in real life. Now, this is the deal. You know, in the Second World War, okay, the Allied, there's something that we call the Allied that actually fought against the Nazis, okay. So they actually seized some weapons, okay. I'm talking about the Allied now, okay. They actually get some Nazis weapons, okay, in their possession. Now, when you take a look at the weapons have serial number. Okay, the weapon actually have a serial number. Okay, now of course the serial number, maybe let me be specific. Okay, maybe the serial number found uh 11, I'm just assuming 292, 116, um maybe 51. Maybe these are the serial numbers found. I'm just assuming. Okay, if these are the serial numbers found and the Allied are trying to figure out what would be the maximum number. Of course, if the Allied are trying to figure out what the maximum number is, because the idea is just like, we take a look at the serial number. The serial number is just like, that is according to how the something is produced. Like this is going to be 11 means, okay, 11 numbers of such weapons have been produced, and they want to know the maximum, what the maximum number is going to be. And if they want to know the maximum number is going to be, do you know the idea? Which means they want to know the capacity of weapons in Nazi arsenal. And if they want to figure out that, they can use the idea of other statistics. This is just a sample. Okay, this is not the minimum. 11 here is not the minimum of all the weapons produced, but the 11 that we can see here is the minimum in our sample. Does that make sense now? It's a minimum in our sample. And the question now is, why is it that we cannot use spies? Okay, why is it that we cannot use those who will just go and spy for us? Those who will go and spy, of course, they basically going to be misled by the propaganda of the Nazis, because the Nazis will have a way to inflate, in order to scare enemy. They can actually inflate the number of weapons they produce. So in this case, we can trust the statistician the more, okay, compared to the spies. So what I'm trying to tell you now, what we want to do today, the idea of other statistics can actually be used to figure out what the maximum number is going to be, okay, which means the maximum number become a random variable. The minimum, at times you may be looking for minimum. Okay, the minimum number becomes a random variable. The median number becomes a random variable. In a situation where the maximum number become a random variable, the minimum number become a random variable. Of course, if the minimum and the maximum become a random variable, the range is also going to be a random variable, because the range is the difference between the largest and the smallest. Does that make sense? It's also going to be a random variable, and as a result of that, we need a probability distribution for them. So what I'm going to walk you through today, I'm going to derive the probability distribution for the minimum. What do I want to use it for? Because I may want to find the average of the minimum, because minimum becomes a random variable. Okay, I will also need the probability distribution of the maximum, because we may need the average of the maximum, because the maximum becomes a random variable. Okay, so those are the things I'm going to walk you through today. Now, take a look at what I'm projecting, x1 up to xn. Okay, they are like this data. They've not been arranged. These have not been arranged. Does that make sense? Okay, now that is x1 to xn. They are random variable. They follow a particular distribution. They actually have a CDF. They have a PDF in case they are continuous. Of course, I've walked you through, the properties of a random variable. Okay, now we now want to order it now. Like for instance, I want to order the one I wrote on the board. Ordering that is like, I want to write them in ascending order, like where I'm going to have, for this one that I wrote on the board, basically going to be 11, okay, 51, okay, 116, 292. Now, let me tell you this. The way they are originally, they follow a particular probability distribution. And after we order them, we now want to seek to get the probability distribution for the ordering. Does that make sense? Okay, so that is what we're trying to say. Like, if you take a look at that, we've ordered. And if you want to talk about ordered, like the moment you say there is x1, that means ordered. Okay, that is a minimum. This guy is different from this guy. Okay, the x1 here is just the one here in the sample, but this guy here is the ordered one. Does that make sense? Okay, and if you another thing variable you can use, you can just use y1. If you don't want to write x1 subscript 1 in that, you can just simply write y1. Does that make sense? Okay, so the x1 become the minimum of that, and the xn become the maximum of that. Okay, now this is what we want to do. We basically need the probability distribution of the smallest. We need the probability distribution of the largest. We need the probability distribution of the median. We need a probability distribution of the range and so on like that. What I want to do here, I'm trying to get the probability distribution. Okay, if you take a look at this now, okay, starting from the minimum and the maximum, they're going to have their CDF. And we believe that from the CDF, we can get a PDF. You remember what we did the other time? By the time you do the derivative of the CDF, that will actually lead to the PDF. Okay, now, if I have a CDF of the maximum, the maximum of what? The maximum is actually written as x small n in parentheses, the source script. Can you see that? That is maximum nth order Okay, now if I want to figure out the probability, the DCDF of that, that is exactly what I'm doing here. Of course, you know how to find the CDF. Take a look at this guy now. Okay, now I want to find the CDF of that guy. It means I basically want to find the probability of x1 less than x, x2 less than x, all the way to xn less than x. And of course, that is basically going to be independent. Take a look at that. That will be independent. Independent in the sense that, I'm actually going to have the probability of x1 less or equal to x, the probability of x2 less or equal to s, and so on like that until I get to xn. And you know what? They are all the same. What I can do, okay, I can just write an uppercase f of x raised to power n. Does that make sense? And which is exactly what I have here. Oh my God, since that is what I actually have now. I think I made a mistake here. Please change this guy to, oh, okay, so I didn't make him, that's Massimo. Okay, now if I have the CDF of the Massimo, okay, which is this guy here, and I want to get a PDF, what am I going to do? I'm going to differentiate. Okay, don't forget, I want to differentiate. That's a composite function, f of x raised to power n. Okay, I'm going to bring down n. N is going to come down, right? Look at the n here, right? N is coming down, right? And inside the parentheses is a CDF, right? When you differentiate a CDF, what does it give? That's a PDF, right? That is what you write out here, right? As a lower f of s. Then you're now going to rewrite the f of x, then everything raised to power n minus 1. Oh my God, what I'm trying to say now, what I'm trying to tell the world, what I'm trying to tell the world right now, give me 1 second. What I'm trying to tell the world is just that this is what you see here become a probability distribution of the largest. Okay, I'm confirming in exam, your actually final exam, one of the question is basically going to be either one of these three. Number one, if you're talking about minimum or maximum or the median, please take notes. So if I ask you, like, for instance, I want to figure out what is the average of the maximum. Okay, what is the average of the maximum? This is the distribution I'm going to use, because this is the distribution of the maximum. Okay, now that is for the maximum. I want to go to the minimum now. Let me tell you this. Apart from application of this in the Second World War, this is now being applicable in other areas of life when you want to talk about auction prices. Okay, where people go, like, for instance, you auction for car, I was always say 5,000, 10,000, 15,000, stuff like that, with the idea of other statistics can be used. What about in insurance policy? It can also be used. Then what about in if you want to improve sampling plan by variable in quality control? Okay, we use other statistics as well. Okay, so this has a wide range of application. Okay, now I want to go into minimum now. I'm also going to start with the CDF of the minimum. Don't forget, there is a minimum x1 subscript, right? Okay, I want to figure out what is the probability of that, of the minimum. Of course, the probability of the minimum is automatically, when I say the probability of x less or equal to something, it's just going to be 1 minus s greater, right? By using the law of complement. Does that make sense? And that's exactly what you see here. Okay, now the greater than sign, you're actually going to have the probability of x1 greater or equal to s, the probability of x1, x2 greater or equal to s until you get to xn. And in the end, okay, you're actually going to have this as the CDF of the minimum. Okay, when you have this one as CDF of the minimum, you want to figure out the PDF. We're also going to do the same, like the way we did the other time, right? We're going to differentiate that. That's what we're doing here, right? When you differentiate this guy automatically, that's what you're going to have. Okay, on this page now, I'm not going to, let me tell you this, I'm not going to ask you to derive anything in exam, but you know what? pay attention to this guy here and this guy here. Oh my God, take a look at it too. The first one is the distribution of the maximum, and the second one is the distribution of the minimum. The two of them are very, very crucial in case I want to figure out the mean of the minimum, mean of the maximum, or the variance of the minimum, or the variance of the maximum. Okay, that's exactly what we're going to do. Okay, now what we're going to do now, I'm actually going to walk you through an example now. Now, let's take a look at this example. Let me tell you the way when numbers have not been arranged. I'm going to use this as an example now. Let's say, for instance, I want to focus on the age of the student that I run now in person. And I want to believe, I start from this guy and I go like that. You are not, the way you are sitting now, you are not sitting according to age, right? Okay, you follow a particular, your age follow a particular distribution. Now, if I now say, okay, if I get to know your age and I decide to order, right? Okay, then I'm now seeking to get the probability distribution for the ordered. Does that make sense now? So if you take a look at this guy here, if you take a look at this guy here, give me 1 second. I'm gonna go back now. Okay, now if you take a look at this guy here, you were told that you have X1 up to X5. They've not been ordered, but they follow uniform distribution. Okay, they're going to give you the distribution of the random variable before, before arranging them in order. Now, before arranging them in order, now we're told that follow independently and identically distributed as normal. We are the, of course, in the, sorry, I say uniform. And when you take a look at the uniform now, okay, of course, in the uniform distribution, I'm talking about continuous uniform that we've done before. We're actually going to have two parameters, right? A and B. A here equal to what? A equal to 0, B equal to 1, right? And you know the f of x for uniform. What is the f of x? For uniform is 1 over b minus a. In this case now, when I plug in 1 for b, 0 for a, what am I going to have? The f of x is going to be 1. Does that make sense? For uniform. Now, and that is why you have this guy here now. Can you see that? That's why they're telling you 1. Okay? Maybe in exam, I may not tell you that. I can just give you the parameter of the uniform. Okay, I expect you to be, to understand the fact that, uniform is actually going to be 1 over b minus a. Okay, now, if a question is asked, obtain the maximum, the probability distribution of the maximum, or the probability distribution of the minimum, please take notes. Okay, now when you go back and look at the formula of the probability distribution of the maximum and that of the minimum, I need you to pay attention to something. There are two things in this formula. Number one is the PDF, f of x. What is f of x? The PDF of the original variables, when they've not been arranged. And what about an uppercase f? That's a CDF, right? Okay, which means I need to obtain the f of x of the distribution before arranging it, and the CDF of the random variable before arranging it. Okay, I actually need that. So now what I'm going to do, since I've already been told here, I've been told that I'm working with uniform. Okay, and the uniform here f of x equal to 1. Okay, what is a CDF? If I basically want to figure out the CDF of uniform, okay, if I want to figure out the CDF of uniform, which actually means I basically want to figure out, this less than that for uniform. Don't forget, I'm actually going to go from 0 to x, okay, and 1, okay, dt. So yeah, I'm actually having 0 to x, and that is going to be x minus 0, which is going to be x. So what I'm trying to tell the world, my uppercase f equal to this, f of s equal to 1. Don't forget, I'm actually using f of s equal 1 over b minus a. Okay, from what you are giving b equal to 1, a equal to 0. Now what I have now, my CDF is x. I know what to plug in. Oh my God, if I want to do that of the, take a look at this guy now that I just circled. What have I done? I'm going to tell you what I've done now. Give me 1 second. What I've just done, if I basically want to figure out that of the minimum, okay, give me 1 second. I'm going to clean this guy up. Okay, now if I want to figure out that of the maximum, then I actually want to use this guy. What am I plugging in? And what is n? The numbers of the variables 5. What is an uppercase f of s? That is x. I just derived. What is the a lowercase f of s? That is the PDF. That's going to be 1, right? Then you can see f of s raised to power n minus 1. Is there anyone in this class who doesn't really understand how I figured this guy out? I've already used the distribution of the maximum. Any question from anybody? Okay, please pay attention to the parent distribution of random variable s when it has not been arranged. You know, here it is given to be uniform. In another question, it could be another distribution. So which means all what you just need to know is what is the PDF of that distribution and what is the CDF. Does that make sense? And what is the numbers of variables we're talking about? It's going to be n. You should be done. So the moment you do that, if you take a look at it now, we have 5x4, right? Based on this 5x4, do you know I'm confirming the question in the final now? You know, based on this, I can ask you to find what is the expected value of this. What is the expected value of the maximum? What am I going to use? You remember integral 0 to 1. Okay. Now, integral 0 to 1 x. Now, the f of xn, the xn. Right now, what you're going to use here is basically going to be 5x4. So 5x4 times x, then you integrate that over the range of 0 to 1, you have the mean of that. The same way, if you want to get the variance, you also need to go by this guy first, okay, where you're actually going to have this guy s squared f of xn, the xn, right? And after that, you can actually get the variance of that now using what we've already done before, minus this guy, right? So please take notes. Okay, now if you want to do the same to the minimum, plug in. This is what we get for the minimum. What we get for the minimum is therefore what we get for the maximum. I can also ask you to figure out what is the mean of that, what is the variance of that, what is the expectation of whatever for that. What we've derived now is what we call the probability distribution of the minimum and that of the maximum, because the minimum becomes, you know why minimum become a random variable? Because you have a sample, you don't have the population. If you have the population of data, do we need distribution anymore? We don't need distribution. But from the population of data, I already know my minimum. Minimum is not going to be random variable anymore. Maximum is not going to be random variable anymore. But the data set you have before you is a sample of data that actually come from the population. Yeah, go ahead. Oh, you know, whether xn, I understand what you mean. You're talking about this guy, right? It doesn't matter. Yeah, it's x is s. I understand. Like for instance now, you know, when you look at the distribution of the maximum, you can see 5x raised to the power 4, right? So that is a distribution on its own that can be validated under the range of 0 to 1, right? So I can go there and do normal statistics like expectation of X. It doesn't matter. I understand what you mean. That's a good question. Okay, now I want to move now. Now, this our further example. Distribution of other statistics, for case n equal to 4. And, the smallest order can be, if I want to figure out what is the probability, like if I have a sample, I have a n equal to 4, what is the probability that the smallest order is going to be less than, exactly 1 less than, exactly 2 less than, the highest is going to be exactly 4 less than, because I'm considering a sample size of 4. I told you the other time, in quality control, they use this idea a lot. In fact, other statistics actually ensure that in the live testing, that will shorten the test time. They're not going to test forever. The test forever is going to, going to spend a lot of money. But with the idea of other statistics, you can actually reduce reduce the test time. Okay, now we may be interested in third order out of 4, first order, third order, and so on like that. And do you know, idea of a binomial distribution can be used here, okay? Because you're talking about n equal to 4. In this case, your p in the binomial parameter is basically going to be a CDF. Why is p a CDF? Oh, because the CDF lies between 0 and 1. You know that? CDF is between 0 and 1, and P also between 0 and 1, because P is a probability. For instance, in live testing, you want to figure out the probability of having a defective item in a company. When you are, when you want to produce something like this, I know you actually have a target value. You know what you are targeting, and at the end of the day, you basically want to see whether what you produce conform to what you specify. That's a measure of quality, right? Okay, so now I need you to look at for K, since we now want to apply binomial here now, for case n equal to 4, I want to figure out what is the probability of the smallest order less than x. Now, smaller less than the smallest less than x is basically going to be 1 for 1. For case 1 is when you have this guy here. Give me 1 second. For case 1, I need you to take a look at this. You see that? That is for case 1. For case 2, okay. For case 3, for case 4. Do you know what I'm heading to? I'm heading to the fact that this is more or less like a CDF of the minimum order. You want to see the pattern, right? When I go back to the general one, this is for samples, this is for n equal to 4. Let's say we don't know what n is. That would be raised to power n, right? Let me go back to the CDF that I showed you the other time. You're basically going to see now what I mean. Do you see, give me 1 second. Do you see this guy here? Can you confirm that? That's for the general case, for case n. Okay? What I just walk you through now, what of n equal to 4, I'm just trying to tell you the idea of binomial was actually used to figure that guy out. Okay? Which is what I have here. Okay? Now take a look at the next one. In the next one, we want to find the probability that the third order, don't forget, we have 4 sample size, 4 variables. I mean, 4 x1, x2, x3, x4, but we are only focusing on the third order. Okay, for the third order, of course, going to be choosing 3 out of 4 or choosing 4 out of 4. Okay, so take a look at what I have here. And in the end, of course, you're basically going to see what this has led us into. Okay, the third order is order that fall between minimum and maximum. I've not walked you through what fall between minimum and maximum. Okay, the third order here, if n equal to 4, okay, the third order here may be something that we call upper quartile, right? Upper quartile, 3 out of 4. Okay, if I have 5 data point and I want to talk about third order will be the median, right? If I have 5 data point, 5, the middle one, after I arrange it, that's the median, right? Okay, please take notes. Now, because of that, I'm going to move to the general case. Take a look at this guy. This is for the jth order. What do I mean by jth order? Do you know this formula? When I plug in j equal to 1, I'm talking about the minimum. That's a general formula. Okay, if j equal to 1, that would be the probability distribution of the minimum order. If j equal to n, sample size n, that would be the maximum order, right? Please take notes. That's a generalization. Okay, so what I'm trying to tell you the world now, this particular formula here can actually generalize the minimum order, the maximum order, depending on what the values of j is. When j equal to 1, you got the minimum order. When j equal to n, you get the maximum order. That's what I mean. Does that make sense? Okay, now we can also have a situation for joints. Okay, why do I need joints? This is the smallest, this is the largest. Okay, let me do this. Okay, you have the smallest order, you have the maximum. Now take a look at this. If I have a plane that look like this, okay, maybe this is 1, this is n, and there are two variables between the smallest and the largest. Does that make sense? Then I'm interested in the joint occurrence of that. That is what I call the GXI, SJ. Do you know when we need this joint? In case we want to figure out the range, distribution of the range. You know what the range means, right? The difference between the largest and the lowest. Okay, situation where, and that is why here we're going to have I and J. I and J, okay? If I want to figure out the distribution of the range, I is going to be 1, J is going to be n. I is going to be 1, the smallest order, J is going to be the maximum order. Does that make sense? So then if you take a look at from the formula, take a look at this guy. Take a look at this formula now. If I want to find the distribution of the the joint occurrence of the order, it's just basically going to be n factorial, because the numbers of ways of arranging n or object in a plane is n factorial. Multiply by the marginals, okay, f of s1 times f of s2 and so on like that. Does that make sense? Oh my God, other statistics is very, very easy. Now I'm going to go to the next one. Take a look at this guy now. Okay, you have this example, n equal to 5, and you are working with a uniform distribution, 0, 1. Of course, you need to know f of s to be 1 for uniform because of the fact that you have 0, 1, right? Don't forget 1 over b minus a, and you know what the CDF is going to be, x. Does that make sense? Now, you want to find for j equal to 1. That's going to be for smallest order. That will lead to this. You can find for j equal to 2, j equal to 3, j equal to 4, j equal to whatever. The last j is going to be j equal to 5. Does that make sense? That's what I'm doing here. Any question on this? What am I using now? Here now, I'm using the jth order. Like this is the formula I'm going to show you. This guy here, that's what I'm using. You see this guy? That's what I'm using. Let me just clean this. Let me clean it off. That's what I'm using. Okay. That's exactly what I'm using. J1, J equal to 1, J equal to 2, J equal to 3. So that is how I figure all of this guy out here. Take a look at that. Any question on this? Now, do you know, I wanted to take note of this now. If I figure for j equal to 1 up to j equal to 5, and take a look at the bottom one. Okay, and somebody said, figure out what is the distribution of gx1 comma x5. I needed to take a look at that. There are two ways you can get that. Okay, now if you want to get x1 comma x5, you can go back here. Give me 1 second. You can go back and let me clean this guy now. Oh my god, do you see that formula, right? Do you see that formula, right? I and j. Okay, you're just going to plug in j equal to 1. I equal to 1, j equal to 3. Or if you don't want to do that, this formula, when you plug in those values directly, you're going to get your result. Or you can come back here. You want to get this guy now, right? What is that of x for j equal to 1? That give you this guy, right? For j equal to 5, right? For j equal to 5, that actually give you this guy, right? Okay. Now, but situation where, let's say, for instance, you multiply this. Okay. If you multiply this, okay, I'm only telling you the condition under which you are not going to use the joint. If you are told that they are independent, you're just going to multiply this by this. But you can see now multiplying this by this will not give you what is here. That shows that they are not independent. So in a situation where they are not independent, this is what you're always going to use. If they are not independent, you're actually going to use the join for them. Does that make sense? Okay. Otherwise, you're going to multiply them. Okay. Now, the useful function of other statistics, like I said, for range, for median, we use it to, because range is going to be a random variable. Why is it that range is going to be a random? Because minimum is a random variable, maximum is a random variable. Then range can be obtained from maximum minus minimum. Then range is also going to be a random variable. Then median is going to be a random variable. Okay. Okay, this is the kth order, the one I called jth order the other time. This is the joint order. Now, let me quickly walk you through another example. Let's y1, this is from the textbook. Okay. Maybe this is one of the questions. Who knows? Maybe for the exam. You know, I told you I'm gonna word for word from the what I've already published on the announcement section. I'm not going to change anything, word for word. Does that make sense? Please master that, because I want the minimum in this exam to be 99 if possible. Okay. Now let y1 and y2 be independent and uniformly distributed over interval 0, 1. Find the probability density function of the minimum. Then after that, find the expectation, which is the mean of u1 and the variance of the minimum. Okay, if I want to do that, of course, the f of y1, since I was told that they follow uniform, each of them will have a uniform. Okay, take a look at this. We're told y1 and y2 be independent uniform, which means y1 follow uniform with parameter 0, 1. Y2 also follow uniform with parameter 0, 1. Okay, so, and that was why I actually, define that PDF as this guy. Of course, you know what their CDF is going to be. For y1, it's going to be y1, right? For y2, it's going to be y2. Does that make sense? That's what CDF is going to be. Okay, so what is the next thing I'm going to do now? Okay, the next thing I'm actually going to do, if I basically want to talk about the minimum. Okay, take a look at that. But oh my god, why am I wasting my time all this way? I'm just wasting my time. Don't waste your time. I can just go directly and use the formula. Do you remember the formula? Oh, let me take you back to the formula of the minimum. Okay, I'm going to take you back to the formula of the minimum. You don't need to waste your time. Okay, do you see that guy? Why can't you use this already? Okay, what is f of x? X, right? What is n? 2. I'm done. So if you take a look at what I have here, take a look at this guy now. Give me 1 second. If you take a look at this guy now, I'm going to come there now. Do you see that? Very easy, right? So I don't need to waste my time all the way. Go ahead. Exactly. That's a very good question. It's because because they are identically distributed. That's why you are right. Mhm. You can see, don't waste your time. Just use the formula. Like, of course, I allow cheating exam, right? Where you're going to write a necessary formula. Okay. So you're just going to plug in. You done. Okay. Now, and the moment this guy here is your CDF, okay, then your PDF will be very easy. All we're just going to do is to differentiate, right? The way you have your CDF. Now, oh my God, when you have your PDF now, you are now ready for inference. What do I mean by inference? You are now ready for expected value of U1. The person that asked question the other time, can you sit down? Take a look at this. We derive this as the minimum. And by the time you want to find the expectation, what happened? U1 multiply that. Do you see that in this one now? So it doesn't matter whether it's minimum or maximum. Okay, so if you take a look at what I have here, since I have got 2 into 1 minus U1, okay, so I'm just going to be, U1 is just going to come in. Can you see that? When I want to find the mean. So what am I finding here? Expectation of the minimum, because minimum becomes a random variable. What is the average? In a in a stochastic world, we are interested in average. We're done. Average is okay for us. So this is a minimum. Average is not the actual value, but average makes sense. Average is an intelligent guess about the actual value. Does that make sense? If we do what we're supposed to do well, the average that we got will give us, a very good sense of what the actual value is going to be. So this is a mean. And if I really want to know how reliable is my mean, this is a mean, right? Then I need a variance. That's how we go for variance. So I want to go for variance now. The variance will tell me how reliable is a mean. Does that make sense? Whenever we calculate the mean, you must also calculate the variance. Even though variance is not the last destination, we're still going to standard deviation. Why is it that standard? Can somebody tell me? Extra credit? Okay. For those of you that have earned extra credit in this course and you've not spent it, okay, I know some of you are waiting for the final result to come in before you start spending in. Immediately you will see your final result. Send me a message that, oh, I've accumulated this also number of extra credit. I want to spend it on my final, or I want to spend it on my assignment, or I want to spend it on the midterm. You earn it. You are going to decide on how you want to spend it. Does that make sense? Now I want to award an extra credit now. Why is it that the standard deviation is preferred to variance when it comes to investigating how reliable is a mean? Can somebody tell me? Go ahead. Is that one? Very close. Variance is the squared. Then what makes standard deviation to be more appropriate? Okay, go ahead. Yeah, because the variance is also an average. Standard deviation is an average. Variance is also an average. So 2 of you are very close. You can send me a message for you. I'm going to give you half points of extra credit. 2 of you are very close. Is there any other person that online or in person that want to tell me why we prefer standard deviation to the variance when we want to tell how reliable is the mean? Of course, you've heard about variance. You've heard about standard deviation. And why is it that we normally reckon with the standard deviation Okay, again.
Because
Oh, give me 1 second. Somebody online. Yeah, say, go ahead.
so for standard deviation, when it comes to the mean, so standard deviation and variance are like variance is standard deviations squared, right? But
Yeah.
when you're talking about mean, um standard deviation is like closer to um standard deviation is like getting um an average away from the mean. So like if you have like 1, 2, 3 and you have the average of 2, um the standard deviation is about the average away from the mean for each individual item within a list of numbers compared to the variance, which is that squared.
Okay. I think you are also saying the same thing about those in person. I'm also going to give you half point, but now I need you to listen now. I'm going to tell you the difference between the two. Okay. The two of them, of course, they measure distance apart on average, whether variance or standard deviation. But you know what? Variance is in square units. Variance is not in the same unit as the mean, but standard deviation is in the same unit as the mean. When you are calculating the mean, you don't square. Do you square when you calculate the mean? No. But when you are calculating the variance, you squared. But if you want to remove that effect of squaring, what do? You take the square root. So that is the reason why standard deviation is preferred to the variance, because of the fact that the variance has a square unit, and that is not the unit of the mean. So if you want to, have a measure, that will actually tell us how reliable is the mean, that measure should have the same unit with the mean. And standard deviation has the same unit with the mean. Does that make sense? Okay, that's why, and there's no way you're going to get to standard deviation without passing to variance. You need to first pass to the variance, right? Before you get to standard deviation. Okay, last question, maximum. I want to do the maximum. Okay, I'm going to go the same way that I go the other time. And that's actually, if you follow what I did here, okay, for the maximum, okay, you're going to say that this is going to be u, this another u, right? Okay, therefore I'm focusing on u2, right? And that is going to be u2 squared because I'm multiplying them. And if this is a CDF, what am I going to do? Differentiator, right? To get a PDF, right? If you differentiate something squared, that will be 2u, right? Okay, this is a PDF. And the moment I get a PDF, I can get the mean. Okay, but you know what? Make sure you check whether your PDF is correct. The total area under a curve has to be equal to 1. You know what I mean, right? Okay, there you go to the variance or standard deviation. Oh my God, this is going to be the end of the lecture for this semester. Okay. Of course, tomorrow I'm actually going to walk you through some practice questions. Okay. And I'm going to give you some information about the final. I think you've already seen announcement section about the where the area the question is going to come from. And of course, tomorrow I'm going to give you a lot of information about the final. Of course, I send you a message that, okay, if you prefer online or in person for the exam, please send me. Like I said, I want to hear from you. And if the final time that I choose is conflicting with your schedule, of course, I'm flexible. Okay, you can also send me a message. I know how to do a makeup for that kind of person. But like I said, the exam is going to be written both in person and online on that same date, same time. I'm going to be here in person, and I'm also going to be on the Zoom. And those that are going to write on the Zoom, we basically turn on their video so that I'll be able to monitor them the way I'm monitoring those in person. But let me tell you something before we meet tomorrow for the practice. Get yourself familiar with those questions numbers that I suggested. I'm not going to go out of those questions word for word. There's going to be 5 questions. you can see there's no chapter 1, right? Forget about chapter 1, chapter 2, 3, 4, 5, and 6. Is there any question before I go to the, yeah, go ahead. Yeah, it's gonna be one. Yeah, you're right. But when I say one, it's not gonna just be one question like that. One question with multiple parts. Yeah, exactly. But from chapter 2, all question from chapter 2, all question from chapter 3, 4, 5, 6. So making 5 questions. Go ahead. Yeah. Oh, that's a good question. For the in-person, I will bring exam document to class, like the traditional way of writing exam, where you're going to write on your paper, okay, then you're going to submit to me. Does that make sense? Exactly. So you're gonna use the exam booklet. Yeah, that would, this to contain question. That's a traditional way, right? But I know, like me, let me tell you, me, I don't like writing exam online. I want to write in, but I'm providing an option now because I'm flexible. There are some individuals that's okay. Maybe because of one or two things, or one, we live in a stochastic world, anything can happen. They can say, okay, there's no way I'm going to get to the exam venue, and I don't want to deny them. Okay, write online if you like. Go ahead. No, it's only gonna be a sheet sheet, like I said the other time. If you have a one sheet, right? You can write at both sides of it, or if you want to have to, but that should be, if you write on this page, you can write on the other page, and if you write on this page, you can write on the other page. Does that make sense? Yeah. Okay. You can type, you can write. That's no problem. Does that make sense? On the sheet. Does that make sense? And on the exam, those of you online, you can decide to type. You can also decide to write. But if you are writing, make sure you write legibly. Okay? Make sure you write legibly. Go ahead. That's a good question. Very good one. Uh, if one of those questions number that I suggested has to do with normal, or some question that will require the use of statistical table, I will provide that in exam. It's going to be like those of you that will be writing in person. I'm going to attach it to the exam document, and those online, I'm going to tell them where they're going to find it. Does that make sense? That's a good question. All what I know is just have confidence in yourself that you're going to succeed. Okay, go ahead. No, no, no lecture note, no textbook. That's why I allow two sheet where you're going to write all possible formula. There's no length to what you can write. You can write and write and write. That's no problem. Does that make sense? Yeah. Any other question before I go ahead? Oh, scientific calculator. Yeah. Yeah. Any other question? Okay. Make sure you stay safe and have a lovely day. Bye for now, everyone.